Hey, hello, and welcome to the show. It's time for John Park's Workshop. Thank you so much for coming to hang out and for your patience as my streaming software entirely rebelled against me. But I was able to feed it a new streaming key, and it seems to have made things happy, so we're broadcasting. We should be out here on YouTube, and Facebook, I think, is back. I think we're back on Facebook. Maybe, and a whole bunch of other places. Looks like LinkedIn and Twitch and X. Maybe that's it. I don't know. But who are you? You are the viewers and community members, and I can keep an eye on you over here in our Discord chat as well as our YouTube chat. So hello to Santush Rao, Beatagraf Avdel Hagen, Dave Odessa. Thanks for stopping by over in the YouTube chat. And right there, look, that's our Discord chat. So if you're wondering where to chat, where to talk to people, if you have thoughts, questions for me during the show, this is a great place for it. It's at adafruit.it/Discord. Look for the live broadcast chat channel within our server there. And who else hanging out here? We got Andy Calloway, C. Grover, Paul Cutler, hello, Squid.jpg. Thin Man, hello, hello. Good to see you all. Andy Calloway, yes. Let's see, what's going on here? The show. So I've got a coupon code for you today, so you can save some money from the shop buying things on Adafruit. I've got a recap of my product pick of the week show from Tuesday. I have a CircuitPython Parsec for you. What else have I got? The, hold on, I'm putting this thing on Do Not Disturb because I'm getting pinged here. Whew. I've got a Learn Guide recap to go over. I have, we'll do a little bit of a Rhino session, a little 3D CAD, 3D modeling CAD session. And I'll talk about the state of some projects. I have some fun little gizmo to show off related to the Game Boy game stuff, which is the Learn Guide I'll be going over. And I think that's it. So let's get to it. First of all, coupon code. If you want to head over to Adafruit and get yourself some neat stuff and save some money while doing it, then that's the coupon code for you. It is impossible. That's the coupon code today. Just type that in the coupon code section on the way out if you head to the Adafruit shop. That's the Adafruit shop right there. I can let me slide this over here to get that out of the way. I can recommend you check out products, the view all next to new products, and see what's in store. We have a couple at the top there that are coming soon, not out yet, but we have all these neat new little NeoPixel pebbles, as Lamore is calling them. They're these sort of embedded little beans of LED built into the strands. You can use these for all kinds of prop and costuming projects they're great for, as well as many other things. And they are NeoPixel compatible. We've also got this snazzy new Raspberry Pi USB 3 hub. That looks super cool. I like the looks of that one. And a whole bunch of neat little sensors and gizmos, and got this new triple amp power monitor here you can plug in and use over I2C to check out the power draw on 3 different high-side devices, and on and on. So go check that out, or just if you've got projects in mind and want to get some supplies and stuff and don't feel like paying full price, well, we rarely make you do that because we have at least 2 or 3 coupon codes every week, and this will save you 10% this week. It is not, as Toddbot points out, a crouton code. Sorry. So that is our product code of the week. Our product pick of the week, mine from a couple days ago, is this thing right here. It's one of my little favorite OLED feather wings. I love to use this thing. And on that show, I give you a big, deep discount on that product just during the show. We broadcast the show from within the product page. And this is a little recap from this week's pick. This week, it is the OLED Featherwing. No headers soldered on, or a pre-assembled version. Sometimes you just want a line or 2, maybe 3 of text, and I kind of like that this one leaves a row of extra header pins open there so you can solder stuff to it. You can put right angle sockets on there and plug into it if it's stacked up in a neat little package. And I'm using these little buttons to change out the text and invert the colors. So you can see here I've got black text on white. It says monochrome 128 by 32. And 1-inch diagonal. These were just notes to myself so I wouldn't forget. And there's back to the initial text there. Some vector I/O based bouncing around of these objects here with Todd's super clever code. We get a nice little effect there. It is the OLED Featherwing 128 by 32 monochrome in both assembled and loose header version. What up, wop, 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 wop. All right, next up, let's do a CircuitPython Parsec. CircuitPython Parsec. All right, I'm just going to focus this camera a little better here on my gizmo. This may be familiar to you if you've been watching the last few weeks. I've been working on using this little Pi portal to do some vector I/O stuff, and today is no different. So, for the CircuitPython Parsec today, I want to show you how I have built a touch rectangle drawing tool using vector I/O. So this is a cap touch. These are cap touch, right? Not resistive touch? I can't remember. Maybe these are resistive. Could be. Either way, it's a touch sensor on top of a display. I should really look that up. And if I want to use this as a little rectangle drawing tool, I am, first of all, going to try to hide the glare there. Is that a little better? Let me get that in focus. There we go. I have this set up to draw rectangles with 3 points. So I'm going to set a start point for one corner. I'm going to set the width with another point, and I'm going to set the height with a third point. So if you follow along there, we can make rectangles of any size we want that'll fit on the screen just using these 3 little tap points. You can also, this is the precursor to sort of a click and drag rectangle builder. So if I set one point and follow the timing properly, we can sort of simulate doing a drag to create a rectangle. And the way I'm doing this is, first of all, I've got some libraries to import. So I've got the vector I/O and display I/O, which work together. I'm using math, and I have the touchscreen library. And then I'm setting up 4 palettes for the colors that I'm using on this. And then I create these 4 different objects. So I'm using 3 little circles as the sort of vertices or points of my describing my rectangle. Those get drawn on here. And then I have the rectangle object itself. So these are all vector I/O shapes. Then I'm doing some display I/O stuff, setting up the touch screen here, and then I create some empty variables to hold the position of the points that I click, as well as some distances that I'm deriving by using a little formula to check the distance between points. So what we do is we start off with, if no points have been drawn, if they're all cleared out, then we know we're drawing the first point. When I click, we just set that point down and move on. Then when I click the second one, I'm not only setting that point, and that's going to be whatever the same y of the first point is, because I'm not drawing skewed rectangles, just 90-degree rectangles. So I'm really only worried about the x-axis there. So I draw the point at the first point's y, the second point's x. And then I'm also finding out the width dimension that I'm going to use later on the rectangle here by using this square root of 0.2x minus 0.1x to the second power. And then I sleep for a second so we don't suddenly draw the next point, or yeah, a little half-second pause there. And then when I draw the third point here, same sort of thing. We set that point down however far over on x we made with the second point. Now we have a new y. And then I'm using that same formula to determine that height of the rectangle. Then I can finally draw this new version of the rectangle with width equals my width from this formula, height equals my height from this formula, and then the starting point is that first point that I created there, first point x, first point y, and then I clear out those variables so that we can do it all over again. And so there we have the makings of the next shape in our drawing program for CircuitPython. That is how you can use a 3-point drawing rectangle inside of CircuitPython. That's CircuitPython Parsec.
CircuitPython
And also, by the way, I'll say there are a number of different ways that we could use, interfaces that we could use for drawing rectangles. I kind of like this set a point, set a second point for width, set a third point for height method. Maybe I'll explore some others if people have favorites, but you'll probably, if you've watched me using Rhino over here, here's Rhino again, you'll find that version of a rectangle drawing UI to be familiar. Here's a click once, and then you can see it's setting the second point x and the third point y. That's that sort of same idea there. It worked well with the type of math that I already had working inside of CircuitPython for the last tool, but you can tell that this is actually created by using 2 points, not 3, so I'm just sort of exposing that middle step there as I create those. So there's probably some other clever ways that we could do that, but that's how I'm doing that for now. So I think, by the way, I'm going to have to brush up on my vector I/O to see what other shapes we have. If I remember correctly, it's circle, rectangle, and polygon. So we'll be able to set a point, a radius or a diameter, and then dial in how many sides it has. So we'll see if that could be a little drag-drop interface or something like that. That might be kind of neat. I know I kind of jokingly mentioned being able to do Bezier curves. I don't think we have that level of sophistication going on in vector I/O. But if anyone is aware otherwise or has some ideas about that, it would be kind of interesting to do some shape drawing, curved shape drawing, arcs, those kinds of things, Bezier curves, spline curves, that kind of stuff would be pretty neat. Okay, let's see. Next up, what are we going to do? I'm going to show, yeah, this is a good opportunity to take a look at this Learn Guide on the Game Boy game development. So I just finished this up the other day. It just went live. So what I'll do is I'm going to head over to learn.adafruit.com. Let me make this page a little bigger right here. And there we go. If you go to the learn.adafruit.com, you can either just go to Adafruit and look for this link up at the top, or type in learn.adafruit.com. Just scroll down a little bit and you'll see this section called New Guides. And here, the first one here is this How-To Homebrew Game Boy Games. And there you can see I've got my original DMG-style Game Boy. It does have I put a backlit screen. I swapped the screen out for a backlit screen there, which turns out, I mentioned this before, is almost impossible to film for some reason on camera. You can't see the thing. It's actually better on an original Game Boy screen or this Game Boy Color. For some reason that backlit screen is impossible to video, I've found. And then in the corner there I've got that Analog Pocket, which has a nice easy to video IPS screen. And there's one of the little flashable cartridges here. So this is a little GIF I made of some of the screens here so you can get an idea of it. I ended up building 2 little rooms, a little bit of interaction with objects and other characters, or actors as they're called. Some events that take place, like when we grab the battery, the little cassette tape falls off the table so we can get that, head in. We can play some music, show a little bit about using the music tracker. So this is the game here. Here's a little video you can check out if you like of some of the gameplay in action. There is the inspiration for this, which was the Dookie Demastered from Green Day album, which plays a song each on some different obsolete formats, including a toothbrush, an 8-track, I forget if that one's a doorbell. I think that's a cheap doorbell that plays back a little WAV file. And there's our Game Boy cartridge we're emulating. And then this goes into just kind of touching on, it's not really a tutorial of how to use GB Studio. That's what I used to make the game, because they've got great tutorials. So I didn't need to reinvent the wheel there. There's a link, you can go, you can download it, you can use their main getting started PDF manual, and you'll be in good hands. There's also a lot of good videos and video series out there. But I do show you what the steps are that I took to build what I built. As well as a little info on pixel editors, how to create the art, and using art packs that you can download so that you don't have to make everything from scratch. I paid $10, I think, for a little set of a bunch of little game assets that were 4-color assets suitable for use in Game Boy games. So this is the page here on Game Boy Studio. So this gives you an idea, especially if you've seen the gameplay that I did. This gives you an idea of what the workflow is of setting up different scenes. Some of them are automated. For example, that Lars Co Games screen pops up immediately when the game is started, fades to the next screen, the start, and then that waits for a user interaction. So you can just click on the different scenes and look over in the settings panel, or the what do you call it? Settings panel? I guess settings panel. Parameter panels off to the side to see how things are set up. Everything pretty much is events that you add. So you can add an event that looks for user input. You can add an event that's just looking for interaction between objects, and then set up the logic for what happens next. Here's an example of changing the game events for interacting with this actor. Here's our music tracker that we use you can also go into a piano roll mode, but I'm using a sort of vertical spreadsheet style music tracker here to make this simple little song loop. Building game assets, testing and debugging, which happens internally with a little emulator, and then exporting to a ROM. So those are the kind of overview pieces of it. I also have a link to a pixel art fundamentals that I'd done on a previous guide to give you some resources and some vocabulary nomenclature. And then this is a sort of more granular look at how I built this game. I started from a template. There's some templated games that you can work with that get you started really quickly. I went with their kind of old school GBS1 template, and took that default game world, which is for an RPG, role-playing game style game, and just deleted a bunch of stuff I didn't need and swapped in a bunch of the graphics that I changed to, and then adjusted some of the interactions. So, for example, we can change the flow between scenes. This little section here on triggers shows these little trigger pads that you can draw on that are at the doorways of my scene. And then we can tell those events. Right now, those aren't going anywhere in that screenshot, but then in the next section here, we look at essentially, oh, if you touch this orange pad, you're going to head to this scene with the player facing up. That's why they pop in the scene, kind of walking in the right direction. And then conversely, we have another little welcome mat pad, trigger pad here that sends you back. So those are the two scenes that you can kind of go between by walking. Anything else is through button presses or other game logic. The assets folder, there's a nice project organization to these so that the game that you're working on knows to look in local folders for assets, and those are what you are given as your choices in drop-down menus. So any little PNG files that I create over in Sprite and put into the right folder will appear almost instantly as a choice in the game. So you can see this was the original house art here. I went and used some of these little assets from a DVA tile set Town and Around pack that I bought off of itch.io, and just used layers inside of Sprite, similar to Photoshop layers if you're familiar with that, or GIMP layers, to drop in some pieces of art, maybe adjust them a little bit, move them around, but I didn't want them all flattened together since we have a floor tile under there. We want to be able to move things around while we're playtesting. So you can save that as your layered Sprite file, but then export PNGs very quickly and easily. And in fact, there's the PNG file right there, and it's a 160 by 144 piece of pixel art, which is the screen dimensions for the DMG Game Boy. Here's swapping that background in, getting rid of some assets we don't want, creating a little Lars piece of art there. You can download that, drop that in, set up the interactions, and then we have the second room. Works pretty much like the first one. And then this one gets a little more sophisticated with some of these actor interactions. When you bump into something, what happens? Not only does that go into essentially your inventory by flipping a variable, but we also deactivate it so it goes away from the game screen so we can't pick it up again, it's gone. And it even sets a variable that gets read by the cassette tape. So over here, you can see I've got my cassette tape up in the corner there. That one has a variable called got_battery, and if we do get the battery when we touch the battery, then we move the tape. That's how it drops off the table and ends up on the floor there where we can then pick it up, so it's not accessible at first. Little info about using the music tracker, and then how to quit the game. We created a little interaction with this glass here, this little martini glass looking thing, to either just continue playing or quit out to the main menu and reset some variables. So then the other kind of impetus behind this wasn't just how do you make a game, but how do you put it onto hardware? How do you put it onto cartridges? So here's an example of a little flashable game cartridge. This one I'll show in a second. Actually, this is a new one I got that runs off of an RP2040, and it's kind of interesting. This is a flasher, so this plugs into USB-C, and then a cartridge plugs into it, and then we use Flash GBX to write our ROM onto a blank cartridge, a reflashable cartridge. So this shows you here in the guide how to export your game. So you can export as a ROM file, and that ROM file is what gets read by any emulator. If there's a HTML player on itch.io that can read that, although it gets kind of exported differently into a little HTML folder structure. And then we can also export pocket files that can be played on that analog pocket. But here, the main thrust of this for the guide is to export a ROM file. I discuss a couple of different cartridges and flashers that are options that you can check out, as well as some of these reproduction ones. These little clone carts from AliExpress that cost more like $4 or $5. And in most cases, those flash just fine. A lot of these commercial ones are, if they're capable of a 512K game, then they need to have some sort of memory bank controller as well as the ROM flash, and those are anywhere from $15 to $30. So if you're making a bunch of something, you can contract someone to do it for you cheaply, or you can get a whole pile of reproduction carts from AliExpress and flash them yourself for a lot cheaper. Here's the software I used, a little info about that, and then there's that video of it playing there. So let me know if anyone has questions or wants more info on this. We are thinking about trying to do an RP2350 version of a game cart. And actually that's a good segue into this one here, which I may have linked or looked at before. In fact, let me just go to it. It is, what is your name? Croco Cartridge. Croco Cartridge. I got mine here on Tindy. I believe it's open source, and you can download a BOM and a schematic and board files and have them made, or you can get one pre-made for you for $30. The nice thing about this one is that it does not require a separate flasher. This just plugs in over USB, and there's a web app that lets you drag and drop a game ROM onto it, and it has a menu. So when you fire this up, it'll say, "Hey, which game do you want to play?" In fact, let me show that here in the overhead real quick, just what the process looks like. So let's see. So if we go to design files, this is the GitHub for this. It is github.com/Shilga, S-H-I-L-G-A. There's just two things in here. There's the cartridge firmware. I might have been wrong about having design files. I thought I had design files, but maybe it's just the firmware that's here. And here is this web app. So if you want to check it out, it's here. You can also let's see, where is the, okay, right here. So localhost 3000. Is that it? Is that going to work? Let's try it. Now I can't remember. I just did this yesterday. So let's go into this down shooter here. Let's see that. Put me in the corner there. So plug into USB like so. And no, that's not it. What is the stand by? Is it under releases? Yeah. Okay. Yeah, cartridge-web.croco-electronics.de. So I've plugged in my Croco cart here. Click connect. Allow that connection. And this will show you it's got, there was a game that shipped on it called Tobu Tobu Girl. And then there's this, is my Dorky Demastered, my game. So those, you can click add ROM here, pick a ROM file, and then once you've added one, you can push it to the cart. So this has it on the cartridge here now. What I'll do is, let's go ahead and plug this into, I'll use my analog pocket. So, you know, this is good for development and for your own needs if you want to back up one of your games and play it on here, or use hacks and mods to play a weird version of a game. But at that price, you wouldn't probably want to deploy stuff or sell stuff with that. So it serves sort of a different purpose than having a flasher and cheap carts. So let's see. I know this one works, Tobu Tobu Girl, on here. This cart worked great on real hardware. I think the Pocket might not love my Dorky Demastered for some reason on here, so I haven't had time to dig into that. But you can see it's playing this game. If I go and quit the cartridge, relaunch it, it's going to go into the little menu here. So I'll pick Dorky Demastered. And I think this is part of the problem. It should not be asking about a real-time clock. I think it's going to crash. I think it crashes in a moment here when I try to start it. It's trying. Play, and then, yeah, it crashes there. Not sure why. But this is, this is an FPGA. This is not real hardware, so it's no fault of CircuitPython. And it's very likely something I can fix in how I'm exporting that game. But I will show you this running on real hardware. So here's a Game Boy Color. Like I said, my real Game Boy DMG does not have a very easily filmed screen. Try to get that glare out of the way. Better? Yeah, so it's not perfect. Let's see. So we'll launch Dorky Demastered. I am curious if I can use this little light here. Yeah, that's probably better. So this Game Boy Color does not have a backlight. It's a reflected light screen, so it really looks best when you pump a lot of light at it. But you can see there. So that's the game. It's running great, and it's running on a Game Boy Color where it picks a different palette than just the 4 colors of green that I had on the original there. So that's running right there on that. And we can restart that and launch the other game just from that little menu. So that one's kind of cool. And I've actually got another thing I wanted to show, and this was, oh, that camera's out. Hold on one second. This was, Toddbot over at the chat said, if only computer displays could be emissive. Impossible. Has to be reflective. Let me fix this camera over here because I want to show you. Brent was asking me about this. We're talking about Game Boy cartridges and ways to play them. I'm actually going to zoom in over here on this TV. A CRT TV setup over here with a Super Nintendo. It's actually a one-chip Super Nintendo clone on there. And the question is, wait, why are you showing a Super Nintendo when you've been working on Game Boy games? That's probably what you're wondering. And the answer is this thing right here, the Super Game Boy. I can't remember if I've shown this or talked about this thing before on the show, but these are neat. These are weird. So this is a real Nintendo product. It's a cartridge that came out, I don't know what year, 96 or something like that. 94. 89 and 94, they've got copyrights on here. So Super Game Boy. It is not an emulator, it's a Game Boy. So this is a redesigned Game Boy hardware that has no input and no screen and nowhere to put batteries, but it's basically a Game Boy. If you were to add battery or power and input and a screen to this, which I wouldn't be surprised if someone's done this. Someone must have turned one of these into a handheld Game Boy. But the way these work is that they use the cartridge connector and the Super Nintendo to get power, to provide input coming from the Super Nintendo's gamepad, and to provide graphics to feed into the video circuitry of the Super Nintendo to send to the screen. And so you just put Game Boy cartridges into here. I can't remember if it does Game Boy Color as well, but Game Boy for sure. And so if I take one of my flash carts that I've put the Dorky Demustard game on, put it in here, we can then put this inside of the Super Nintendo and use the Super Nintendo as a giant screen, which for a Game Boy game, which is pretty cool. So let's, yeah, let me get that out of there, and let's just plug this in so you can see it in action. Sorry, it's kind of far away. So I'm just plugging this cart in, power it up, and I think I'm on video. Come on, video 1. I'm going to actually pull my cart out first to make sure that it's registering the Super Game Boy. Oops. Okay, so there's the Game Boy, Super Game Boy. And it says, hey, you don't have a Game Boy cartridge in there, and it won't show the logo because the Nintendo logo is actually on the cartridge. So I'm going to turn that off and then reinsert the Game Boy cartridge in there. Super Game Boy. Larsco Games, and you'll notice it has yet another set of color palettes are available on these. But it's just going to be 4 colors, but they can be repalletized to whatever you want, or whatever options this has. Same game. So actually, I'll show the full game here. So here we go. We got, hey Lars, what's going on? Lars says, hey, you should play some music. Get batteries and a tape. Okay, thanks, Lars. So I can check things out here. Go into my little room here. So here's what I was saying before about I can't get that cassette tape because it's too high up for whatever reason. Giant battery. Let's go get that. Hey, beep beep, batteries. Nice. And the little cassette just fell over. Go pick that up. You got the tape. Okay, we can get back out of here. So again, it's just standing on that little trigger point is what switches screens. And now, actually, if I go interact with Lars, he sees that variable that we did get the cassette and the battery, so it just says you should play some music. He doesn't tell you to go look for a thing you already have. Now if I go up to the radio and interact. It's going to play and play and play. And then I can go continue, and just leaves everything alone, just gets out of that menu, or quit, and it goes back to this screen. Let's go ahead and start, and we'll pause right here. If I hit both shoulder buttons on the SNES controller, that brings up some higher level settings for just the Super Game Boy. So we can go and pick different palettes here. So here we have A through H, and then there are 4 sets of these. So if I go to H and stay on H but hit 1 or 2, this is kind of the monochrome palettes over here on the side. There's a very Game Boy reminiscent one, or a more olivey version of that. So you can then also just go and pick stuff you like. There's all kinds of wacky things you can get on there. There's a kind of a neat pinksy, purplesy, ooh, that's kind of inverted one. And then you can get out of this menu here. So now you've just repalletized the game into a different look. You've also got borders, which is neat. So by default, it just has this shell of a Nintendo Game Boy. You can go to no border. I kind of like this one here for this, which is this room we're inside of. So if we close that and go back to palettes, we can pick kind of an appropriate palette for this room. Oh, those are terrible, actually. I don't like those. Let's see. No. Sure, we'll use that. I like that. And then there's a couple other things you can do with adjusting which buttons are mapped to what. And then these have to do with painting your own paintings, so just kind of a paint program, or using your paintings as the border thing here. I can just get out of that. So you can see if we go and quit this now, that's the Game Boy part. This is the Super Game Boy part here. And then the piece of this that's important that I can't remember which hardware, I think it's using Game Boy audio hardware for the 4 channels of sound that are on the cartridge as well. So I think those are pretty much the same as a Game Boy, so it shouldn't sound very different. I think the only real difference that I know of is this may have a slightly faster clock speed than a handheld, and I can't remember if it's like different between PAL and NTSC and the Super Game Boy, but there's, I think, a slight difference between clock speed of your game playback depending on if you're in a Super Game Boy or if you're in a handheld. So that right there is the Super Game Boy. So kind of a neat way to develop your simple game using Game Boy Studio and then get it onto a TV if you're into hardware, if you want to use hardware. Of course, you can use an emulator and play this back on anything. You could play it back on the Madison Square Garden Dome in Las Vegas if you wanted to, I'm sure. But for me, for what I've got laying around, this is kind of a neat setup for doing this sort of thing. So that's some of our... it does look like CGA colors, doesn't it, Andy Calloway? Yeah, and I think you can look around online and find complete lists of all the palettes that are available on that, because I think people have then put those onto like emulator handhelds and things. So there's a rich world of documentation of all this stuff, which is pretty neat. Okay. Excuse me. Last sort of Game Boy related thing for today, and maybe for a while, is to do with this Game Boy Color and this cartridge here. So I don't know if there are any others. I think it may only be the Game Boy Color that has an infrared emitter and receiver in the top there. So hidden under that little window there. I think in a second I'll show you why and how we can use that. I don't know that it'll show up on camera. I think these are filtered. Maybe one of my cameras will show purple, but there's a IR transmitter and an IR receiver built into the Game Boy Color, which I have not looked up recently what all the different uses of it were. I'm assuming some of it was transferring Pokemon stuff between friends. Obviously, it's limited, a pretty slow data rate, so you're not going to do multiplayer gaming with it. But I think just for trading stuff is the idea behind it. And this is also in the era of the Palm Pilot, so being able to zap info between things was kind of a thing back in what's this, 98? No, is that, when the heck was this thing? When was the Game Boy Color? It might have been 98. Sure, we'll say that's what that says. I'm just looking on the bottom here. But can you read that? Let's get in close. Let's see how close this will focus. It's got like a little bit of a... .98, yeah, it says 98. It's actually easier to see on this camera than in real life. It's a little nick in the label there. So 98. So the reason that this is our coupon code today, Impossible, is that there is a game for Game Boy Color that is a Mission Impossible game that just for fun has this sort of PDA functionality in it that includes an IR transmitter, and it's actually a universal learning remote style thing. So I might have to adjust this as I as I find the right distance. But what I'm going to do is turn this game on. And the nice thing is that it's one of the first menus is, hey, do you want to play the game or do you want to ignore all of that and use the SPY PDA? So I'm going to pick English and then play the game, or, nah, forget that, I'm going to use the agent organizer. So if we go over to this agent organizer, we can do remote control. There's a calculator. We can receive transmissions. Reset a database or exit, or secret files. So I'm going to go to the remote control. And you can basically set up 4 different devices. It'll learn some remote codes for, they're saying, your TV, your VCR, your satellite dish, and your stereo. But I think those can be kind of anything you want. It's just a way to organize them into sets. So if I pick the cool little CRT there, it says learn signals or send signals. So what I'll do is I'm going to grab a remote for one of my TVs over here. And here you can see, actually, yeah, let's see, can you see this one flicker? Yeah, you'll see a little blink, 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 right? So I'm gonna learn the power on, that's what that button was, code on the A button. So this, let's get the lighting right. So this is in learning signals mode, and then we can pick a button and learn on that button. So I'm going to click on my A button, and you can see it's blinking here. So it wants you to send it an IR signal. So I'll go ahead and click this one right here, and it just learned it. And then for B, we'll change the input. So I'm going to click B. That's blinking, wants to learn something. I'm going to click the TV video button on my remote. I just learned that. And we'll do volume up. Volume up. And volume down. And then for right, we'll do picture up, and left we'll do picture down. All right. And then we can exit that and switch over to send signals mode. So this should now send signals. So what I'll do is flip this view over here. Oh, look, I didn't know that there's a little screensaver there of Mario sleeping on my Super Game Boy. So now with the, what's the best way to see this? Maybe like this. Now with the Game Boy in send signal mode, I can press A. Actually, let's not turn it off. Let's change the input. So video 2, video 3, TV, video 1. We can adjust the volume. We can deal with picture, make that a little brighter. And then we can turn it off and on. So let's see, can you actually, there's no way to see all these things at once, but here we try it. Off. Bzzz, and on. And there we go. So that is the crazy little remote agent universal remote thingamajig. You can see, should be able to see a little purple. No, I'm not seeing it on here. Maybe they've got thicker filter and lower power. Oh, I see it. Just a little faint flicker of it. Yeah, it's hard to see. This one's brighter. But I love IR and I love weird stuff like that. So that's the strange hidden feature of the Game Boy Color. Not so hidden, but a fun way to check it out. On the Mission Impossible Game Boy Color game. So there you have it. Weird, fun stuff. All right, this is probably a good time to, again, remind you, you can go get some cool stuff at the Adafruit shop and get 10% off today with that right there, Impossible. It's your coupon code for today. And now I'll let me give you just a little bit of a project status on the animatronics. So last week I took my $25 Frosty the Snowman here, who dances and sings, pulled them apart. So what we learned from that is this right here. I'm just going to keep a finger on here to keep a part from falling out. These are the two functions it has, which is when it runs the motor forward, arms move back and forth. When it runs the motor backward, it raises the arms. So it's just going between forward and reverse on a DC motor. So could try to get servos in there so we can animate that a bit, but I'm going to look for something bigger that has more functions that we can do more with, I think. So we'll see. The one interesting thing about this one is I think it is a really good fit for Lars. So depending, just chopping the legs off, basically the armature of that is, and there's not much here other than the batteries, which we could put somewhere else. But it is kind of an interesting, good fit. So I think that's a good one to have. We may do something with Lars with that, but I'm also going to look for something that I could use a couple, 3 servos with. Another piece of it, so I showed last time BotTango, which is the animatronic rigging and animation software that I was using. That was communicating with Arduino and a shield. I was using our little, lift this up so you can see it, our little PWM shield that can do 16 servos. That is one way to talk to devices. I'm interested in seeing about getting the little Bioloid or Robotis Dynamixels. These are more sophisticated servos that can chain the data serially from one to another. They're higher powered, they're higher quality, they're better mounting stuff, and they speak a TTL signal to each other, a serial TTL signal to each other. The question is, with the Robotis, or sorry, with the BotTango software, in fact, I can pull that up. You've got an option for Dynamixels, and it has a different, rather than it trying to talk to the Arduino, it just wants to go USB to serial with a particular protocol. So let me make this visible to you here real quick. And I'll shrink that. Let's just make a new project. So if I create a part in here and pick a Dynamixel, this allows you to select the model. So I'm using these AX12A models. Protocol 1, there's 2 different Dynamixel protocols. And then when we go to set up the driver, there's just one default Dynamixel driver here. You pick a output. I'm going to try to see, more suggested that perhaps one of our USB to serial converters will do the same thing as their. The documentation for this says that just use the Dynamixel or the Robotis brand U2D2, which is like USB to Dynamixel gizmo, little box thing. But it seems like we might be able to just use like a serial TTL cable or a serial RS-232 cable. So we'll try a couple things there and see. We'll see what we can do. So, question in the chat is, what software is this? I think you're talking about BotTango here. That's White Links, and this is called BotTango, B-O-T-T-A-N-G-O. And I had used it to build this. Let me reopen that. Little 3-axis servo armature rig thing last time. It's this right here, yeah. So this, I didn't put any pretty geometry in there, but this essentially allows me to rig the hierarchy of servos and then go in and use some nice animation tools to keyframe animate those servos. So this is just like a little test I put it through, but with the servo plugged in and hooked up and linked on the proper port, the software just talks directly to the driver on Arduino and drives your servos around. So I'll be coming back to this as I put together this sort of holiday animatronic. So that was just an update that I am right now looking into the Dynamixels. They have a few neat characteristics that we want to play around with. If anyone has experience with Dynamixels and not their driver, but just using USB to serial cables, I'd love to hear about it and talk to you about it so I can shortcut that and get that up and running. Okay, so let's see. That is what's going on there. Last thing I wanted to do then is just do a quick continuation of 3D modeling tips and tricks in Rhino that are applicable all over the place. Go back to the top view and kill these squares we're looking at. And in the last couple weeks, I've been looking at the procedural workflow of parametric modeling in Grasshopper, Rhino plus Grasshopper, which is very similar to most of your parametric CAD programs. This week, however, I just want to talk about another hands-on technique that then we'll later use in some of our procedural building. But I'm talking about making a procedural case builder that we can put a feather into, or a QT Py, or a Metro, or an Arduino, different microcontroller that has different size and different hole spacing, which is what we worked on the last couple weeks. But one of the fundamental things to doing that is making the actual box that fits that and put a lid on it, carve some parts out, and so on. So I'm just going to show a kind of very hands-on version of making the box that you might make for this sort of thing. We can go back over to the grid for this. So I'm just going to start with, let's do it a little bit like we would procedurally, but just by hand. So we would maybe give it some coordinates for a layout for the overhead drawing of the size of the thing, the dimension of the thing. So we've got a little square here. We'd extrude that into a box of some size. Let's say something like that. Let me put it into an X-ray mode so you can kind of see it but still see through it. So we've got our footprint dimensions that are going to be a little bigger than whatever the gizmo is that's going inside. We have some height dimension that we've given it, and then in this case, we're going to put a lid on it. So one way to quickly build a lid for this kind of thing is similar to if you've ever built a box out of wood. You kind of build a sealed box and you cut the lid off on your table saw and you've got the two matching pieces. So we'll do the same sort of thing. In this case, I'll make let's make it just a larger rectangle that doesn't have to be all that precise. So you can see it sitting down here. We'll lift that up to wherever our lid is supposed to be. Let's come up a little higher than that maybe. And let's make a planar surface out of that. So we would turn that rectangle that's at a certain height into another surface, and then we'll be able to cut this surface out. So let me, we'll try it by, do we want to do it this way? Yeah, let's make our inner thing too, because normally we would have made the inner smaller box that we have sort of a thickness to the walls. So I'm going to use an offset surface to do that, and you can see it's saying, okay, how far away do you want and in which direction do you want an offset of the existing surface. So we'll make this say 2 millimeters, and I want it pointing in. So we're just going to make a second surface that's just shrinked in the proper amount. So there you can see I've got a little 2mm wall. Let's make that a little bigger, in fact. And again, you can see this is why it's nice to do this with your procedural tools rather than by hand, because now I'm going back and forth and undoing things, but this will lead up to us doing it parametrically later. Okay, so here's my, what have I done? Let's do offset surface for, oh, I want sharp corners. There we go, that's why it was confusing me. Oh, why is that cutting itself out? I have some funny setting on, don't I? You look at it as a shaded object. All right. Offset surface, distance 4. There we go. Okay, so now we have this separate surface. I'm going to, we could either cap them and turn them into real boxes, or actually I kind of like that we can see it exposed this way, and then we'll cap it later. So now what we're going to do is cut these guys with this plane that we've put here. So this almost you can think of as our table saw that we're running the box through. So I'm going to pick both of these and say split. It says, what do you want to cut with? I said, look, cut with that thing. Okay. I actually don't really need that thing anymore. I can delete that, get that out of there. But now, if you look in my X-ray view of this, we've got kind of the box and the lid. So I can pick these and connect their faces to each other. We can offset down from the top. We got a bunch of options. I'm going to actually undo a step here, and I'm going to do it the other way I said I could do, which is let's make it a real box. So I'm going to cap that extrusion. So now that's a full box. I'll do the offset surface, flip that around. There you can see inner box, outer box. This will work a little better, I think. And then I will pick both of those and say split. There's my table saw. Get rid of the table saw. And now if I just drag these away so you can see them a little better, we're almost there. In fact, I'll go to a shaded or a rendered view. It makes it even easier to see. So we're close, it's just we need to bridge these gaps between them so they turn into two pieces instead of 4. So let's go back to shaded, and we can either cap and boolean, or we can do a little loft. Let's try a loft. So loft to loft. Yeah, so just a set of these will work. And again, I'll reiterate, you can learn a lot about the construction technique you want to use by doing it by hand, because it's pretty immediate. But then when you do it as a procedural network of nodes connected into each other, you stop having to do any of the tedious stuff and just make little connections. So I'll just finish this the tedious way. And then we'll join these. Okay, so right now we still have separate little surfaces, but I can grab them and join them up. And that will just make a single watertight closed polygon or poly surface. Not polygons, NURBS. NURBS poly surface. So there you go. We can lift that up and out of there. You can see now we got our nice little box. And any of the techniques that we use to adjust that initial box will carry over into that second one that's made from it. So if we wanted to have filleted or chamfered corners, we could do that on just one box, and then everything else should get derived from that. So, so this is the setup. I'll do a more procedural, parametric version of that in Grasshopper maybe next time, and we'll fit the actual case into it. And then with these, something I like to do either again with drawings and constrained drawings and basing things off of dimensions, like parametrically say, okay, a third of the way between these two edges, we're going to put a circle with a diameter that's a ratio of the size of the thing. But again, when you're starting out, if you're saying, hey, I want to put like a USB plug in this section right here, you can measure out a little stand-in for that, put it somewhere, and cut it out. So if I pick this and this and do, actually let me just pick this one, Boolean difference, get rid of that. Now we'll have a way to put little holes in things for the buttons that you need access to, the USB, the switches, and so on. So a lot of the case designs that you see will involve this sort of technique. We get dimensions, we extrude up a box, we give it a lid of some kind, maybe round some of the corners so it's pretty, and then add in holes in some of the sides or in the top for buttons and LEDs to be seen, add some provision for screw holes, maybe we'll add in little screw posts and bosses and stuff like that, but that's the sort of general hands-on starting point of that kind of thing. All right, so that's the little tool tip of the day, is just some manual building of a box. Let's see what questions and things we have. Whitelink says, very similar to how I generate board mounts in my solid Python OpenSCAD library, SPKB. I haven't really added more boards yet, but it already generates mounts for the ProMicro and STM32 Blackpill. Very cool. Since it's OpenSCAD, it's all built with solid primitives and CSG ops, but the same idea. Really nice. Let's see. Over in our YouTube chat, Mike Jones says, would love to see AI learn to walk with those servos. We can just type run up the chimney and your little gremlin can do it. Heck yeah, terrifying. All right, let's see. I think that that's going to do it for today. I will remind you again, if you want to save some money in the Adafruit shop, just type in this coupon code today until midnight today, East Coast time. It is impossible, in honor of the Mission Impossible cartridge that gave us our IR blaster today. And that will serve you well if you want to go buy some cool stuff today. Maybe buy some servos and build some robots, who knows. All right, thanks everyone for stopping by. We have, I believe, a deep dive with Tim, Foamy Guy, tomorrow. Should be a Desk of Lady Ada at random Desk of Lady Ada times over the weekend. I'll be back on Tuesday with a product pick of the week. Wednesday we'll have 3D Hangouts, Show and Tell, Ask an Engineer, and Repeat, and more, and more, and more. So thank you all so much. For Adafruit Industries, this has been John Park's Workshop. I'm John Park, and I'll see you next time. Bye-bye.